welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We are here to help you land your next big offer. All right, today we're going to talk about this easy problem, major element. So I call it easy because there's so many ways to implement this. However, I would highly recommend we go through all the methods so that at least we know what's going on. So the problem is a given array, find the major element. What is a major element? So it is the element that appears more than the floor of n divided by 2 times, and it's guaranteed that the array is not empty, and then the major element exists in the array. So that pretty much means, for example, if you have an array size of 1, so that element is the dominant element, major element. If you have 2, then if it's, let's say, if 0 and 1, it doesn't really make any sense because both can be considered major element, which in this case they shouldn't really appear. So there's multiple ways to do this, right? So if I were to think about this problem, my easiest way to use a hash map and then just go through the array. So that is O1 time, but it requires O1 space. The interesting problem is actually this voting algorithm. So essentially it works if you close your eyes, you think about it, right? So it is like different cases. Let's say there's a 5 elements, 0 and 1. So if the major element, if it's always major, so if you just record this element and then record the appearance, so in this case your appear to be like at this moment is 3, and then okay, what happened? Okay, it's 3, and then you minus, and then whatever you recorded, this 1 can be returned as a dominant element. So similar things, if you have 1 0, you increase by 1, then you divide it by -1, so it's basically 1 0 is 0, but the next element is 1. You increase, and then later it will be returned by 1. So even you have cases like, let's say it looks like this. You have 1, now the major element you consider 0, but if you decrease by 1, now the vote is 0, right? So now the next element you see is a major element because it guarantees is larger than n divided by 2. So that said, the algorithm we can implement is like this. We keep a vote and then we keep the major element. And you go through the array. If the vote is 0, so you basically record the current element, or else if the major element is equivalent to the existing one, you plus, or else you minus. So this is kind of like a poor implementation. The optimized implementation looks like this. Give it a better name, major element. And then if the vote is 0, it's like it means it's right now it's already kind of like a zero. It's like a zero-sum game, right? It's already zero-summed, cleared. So whatever the element you see is a major element, or else if it equals to the major element, you plus 1, or else you minus 1, and then later you return the major element. That's relatively straightforward. Let's take a look at what the Leetcode official solution says, but I also attached this PDF in the blog as well. So the first one is like they use the absolute like a worst brute force one, is like for each of the elements is counting the counts. Definitely don't come out with those. Hash map is okay, like I talked. Just iterate through the array using hash map, keep a count, and then later go through the hash map again. Or you can stop early, as long as the number is larger than n divided by 2, you can just return. It's guaranteed to be 1. Sorting and log n, you sort it, and then the element in the middle will be the 1. And then the randomization, don't even think about it. It's so kind of like silly. You just keep randomizing 1 and then just see, but see the time complexity is infinite because you never know. It really depends on your implementation of the randomization method. Divide and conquer, this is actually pretty interesting. This is almost like implement a kind of like a merge sort. So you just kind of like doing it. This is more like a post-order traversal type of thing. You keep recursing it left and right. Once the left and right occurred, I don't think the code is attached correctly, but yeah, because I choose to save the PDF like this. I'll fix this, but essentially, let me see if I actually have it opened here. No. Do I have it here? Okay. Okay, it looks like this, right? So now is the advantage to actually look at the video. So once you have this, which means you already kind of like sorted the left, you're recursing through the left and the right, and after this moment you are counting what's the major dominant element in the left, so left count, and what's the major dominant element of the right part, and then Yeah, so let's see. So this is pretty much int number. So at this moment, you already know kind of like what is the left and the right. You return left count larger than right count. Let me see. I didn't read this very thoroughly. Major elements. Base case, if the only element in your size is one, the major element, okay? And then you keep recursing. You divide it. You choose the middle index. You keep recursing left and keep recursing right. 2 elements half and return it. Otherwise, count each element and return the winner. So you count from the left part, and then you count from the right part. And then while you are counting it, you are essentially just saying, okay, for each of this, if number equals to number, count plus plus. So essentially, you are counting the potential winner of this number, and then what do we pass into the number? The number is just the left and the right. Okay, yeah, I guess that is actually right, because this left and the right, essentially, once you recurse it down to its element 1 is its element itself. So then it basically just recursively return you what is exactly the dominant element through the left or right. So essentially, this is not really the leftmost or rightmost. It is actually the dominant element in this array. And then you merge these two together. Which one has actually more dominance, and then you return that element. It's not the best way, but the best way is this actually called the Boyer-Moon voting algorithm, but it's actually relatively easy to understand. This is a very good solution. That's all. Just leave any comments if you have any questions. Till then, see you guys next time. Bye.